Hello and good day. Welcome back to our class. This is teacher Onen Guzman. Our topic for today is graphing polynomial functions. Specifically, we will use the leading coefficient test. The leading coefficient test will help you to determine the end behavior of the graph of polynomial functions by looking at the degree and the leading coefficient so that it will give you a rough sketch of the graph. The end behavior is a description of the values of the functions as x approaches positive infinity or negative infinity. The leading coefficient and the degree of the polynomial function determine its end behavior and is very much helpful in graphing polynomial function. Let's have here the tabular form of the polynomial end behavior. So let's consider the first case. If the leading coefficient is positive, and if the degree is even, so the graph is opens upward. So the end behavior, so the graph rises to the right and rises to the left, as we can see on the graph. While if the leading coefficient is negative and the degree is even, it opens downward. It means the graph falls to the right and falls to the left also, as we can see on the graph. On the other hand, if the leading coefficient is positive, it means that a is greater than 0 and the degree is odd, so the graph rises to the right and falls to the left, as we can see on the graph on the third example. On the other hand, if the leading coefficient is negative and the degree is odd, so the graph rises to the left and falls to the right, as we can see on the illustration. To illustrate the leading coefficient test, let's have example number 1. On the positive leading coefficient and even degree, say for instance, we have the function f of x is equal to 2x to the fourth power minus 3x cubed plus x minus 1. So the first step is identify the leading term, its leading coefficient, and the degree. So we will take the term 2x to the fourth power. So 2 is the leading coefficient and it is positive. 4 is the degree and it is even number. Second, identify the end behavior of the graph. So the graph rises to the right and rises to the left. The third is graph, meaning to say the leading coefficient of the polynomial is positive and its degree is an even number. So this is the rough sketch of the graph. Let's have another example, this time on the negative leading coefficient and even degree. So we have the function f of x is equal to negative 3x squared minus 6x plus 4. So the first step is identify the leading term, its leading coefficient, and degree. So we have negative 3x squared. So negative 3 is the leading coefficient and it is negative. 2 is the degree and it is an even number. Number 2, identify the end behavior of the graph. So the graph falls to the right and falls to the. So the third one is to graph, meaning to say the leading coefficient of the polynomial is negative and its degree is an even number. So the graph shows it opens downward. Let's move on the positive leading coefficient and add degree. So let's have the function f of x is equal to x cubed plus 5. So again, the first step is identify the leading term, its leading coefficient, and degree. So we will take x cubed. So 1 is the leading coefficient and it is positive. 3 is the degree and it is an odd number. Step number 2. Identify the end behavior of the graph. So the graph rises to the right and falls to the left. Third step, graph. So the leading coefficient of the polynomial is positive and its degree is an odd number. So we have this illustration as we can see. So it, okay, rises on the right and falls on the left. Let's have the fourth example, this time on the negative leading coefficient and odd degree. So we have the function f of x is equal to negative x to the fifth power plus x to the fourth power minus 2x cubed plus 1. Again, so the first step is identify the leading term, its leading coefficient, and degree. So we have negative x to the fifth power. So we have negative 1 is the leading coefficient, and it is negative. 5 is the degree, and it is an odd number. Second step, identify the end behavior of the graph. So the graph rises to the left and the graph falls to the right. So this one is graph. So the leading coefficient of the polynomial is negative and its degree is an odd number. So this is the rough graph of the given function. Now that we have an idea on the end behavior of the graph, let's move on to sketching the graph of the polynomial function. So let's have example, sketch the graph of the function x cubed minus 2x squared minus x plus 2. So the first step is determine the end behavior of the graph. So we will take in the leading coefficient of x cubed. So the leading coefficient is 1 and it is positive and the degree is 3 and it is an odd number, thus the graph rises to the right and falls to the left. Second step, find the x-intercept, meaning to say we will let the function is equal to 0. So we have f of x is equal to x cubed minus 2x squared minus x plus 2 will become 0. Again, using the factoring technique, so we will use now here the factoring by grouping. So the common factor between x cubed and negative 2x squared is x squared. So we have here x cubed divided by x squared. So we will give us x, while negative 2x squared divided by x squared is negative 2. Next, the common factor between negative x and positive 2 is negative 1. So if I have negative x divided by negative 1 will give us x. And positive 2 divided by negative 1 will give us negative 2. So again, factoring further, I have x squared minus 1 times the common factor of x minus 2. Now, so it will result to difference of two squares. Again, factoring further, so I have here x plus 1 times x minus 1 times x minus 2, applying the factoring of difference of two squares. Now, I have now in factored form, so I can easily find the values of x. So here, I have x plus 1 equals 0, x minus 1 is equal to 0, and x minus 2 is equal to 0. So therefore, x is equal to negative 1, x is equal to 1, and x is equal to 2. So therefore, the x-intercepts are negative 1, 0, 1, 0, and 2, 0. So it means that the graph will pass through negative 1, 0, 1, 0, and 2, 0. So the next step is we will find the y-intercept, meaning to say we will let x is equal to 0. So we will substitute x is equal to 0 to all values of x. So we have here 0 cubed minus 2 times 0 squared minus 0 plus 2. So we have 0 minus 0 minus 0 plus 2. So f of x is equal to 2. So the y-intercept is equal to 0, 2. Next step, step number 4, is we simply sketch the graph. So take note that a while ago we have the x-intercept negative 1, 0, 1, 0, and 2, 0. Okay? So these are the x-intercepts. While 0 to is our y-intercept. And take note that since the highest exponent is 3, so meaning to say we will have only, guys, 2 turning points. So the turning points meaning to say it will determine whether the graph is increasing or decreasing. So the turning points of a graph occurs when a function is changing values. So again, so the highest exponent is 3, so therefore that is the number of turning points is 3 minus 1 is equal to 2. Sometimes polynomial functions has a factor that occurs more than once. This makes a multiple root. The multiplicity of root r is the number of times that x minus r is a factor of the function. So when the real root has even multiplicity, the graph of f of x is tangent to the x-axis. When the real root has odd multiplicity greater than 1, the graph bends as it crosses the x-axis. Let us consider the next example. So let's sketch the graph of the function y is equal to x plus 1 times x plus 2 squared times x minus 1 squared. So, the first step is determine the end behavior of the graph. So we will take in first, okay, the highest exponent that we can derive from the function. Meaning to say, if we will multiply here, x plus 2 squared, meaning to say the highest exponent here is x squared. Then we have x minus 1 cubed, the highest exponent is x cubed, times x squared times x will give us x to the 6th power. Next, so the leading coefficient is 1 and it is positive, the degree is 6, and it is an even number. Thus the graph rises to the right and rises to the left as well. Step number 2 is to find the x-intercept. Since we will let the function y is equal to 0, since this is in the factor form already in the form of x plus y times x plus 2 squared times x minus y cubed, so we will have 0 is equal to this function. Then, we have x plus 1 is equal to 0, x plus 2 squared is equal to 0, and x minus 1 cubed is equal to 0. Now, so x plus 1 equals 0 now. So, which is equal to x is equal to 1. If we will extract the root of x plus 2 squared is equal to 0, we'll come up with x plus 2 is equal to 0, or x is equal to negative 2. Similarly, if we will extract the cube root of x minus 1 cube on both sides of the equation, we will have x minus 1 equals 0, or x is equal to 1. So we have negative 1, 0, negative 2, 0, and 1, 0 are the x-intercepts of the given function. So it means that the graph will pass through negative 1, 0, negative 2, 0, and 1, 0. So the next step is find the y-intercept. So meaning to say, we will let x is equal to 0. Since this is already in the factor form, so we will simply substitute as x is equal to 0. So we have 0 plus 1 times 0 plus 2 squared times 0 minus 1 cubed. So simplifying it further, we have 1 times 2 squared times negative 1 cubed. Again, so we have 1 times 2 squared is equal to 4 times negative 1, so we have negative 4. So we have 0, negative 4 as y-intercept. Fourth step is sketch the graph. So we have now negative 2, 0, negative 1, 0, as well as 1, 0 are actually our x-intercept. And our 0, negative 4 is our y-intercept. And take note that we have 1, 2, 3, 4. So we have 4 turning points. And take note that 4 is less than the highest exponent of 6. And also, the polynomial function of the nth degree cannot have more than nth roots. So meaning to say, we have actually the highest exponent is 6, so we cannot have more than 6 roots. Talking about the multiplicity, notice that the graph where your 0 is negative 2, the given factor is x plus 2 squared. So we have here, meaning to say that the factor x plus 2 occurred twice when the real root has even multiplicity. So the graph of the function is tangent. the x-axis. It simply touches it but does not cross the x-axis. This is true for even multiplicity. The exponent is even. Thus, negative 2 is of even multiplicity 2. Observe that the graph where the 0 is 1. We have here where the given factor is x minus 1 cubed. When the real root has odd multiplicity, the graph bends and it crosses the x-axis. Hence, 1 is an odd multiplicity of 3. So, we have here x minus 1 cubed. It crosses the x-axis. So, again, that ends our lesson for today. So, this is Teacher Oni de Guzman, and hopefully that you have learned well. Don't forget to subscribe to my channel so that you will be notified about my new videos.